Hey everyone, welcome to another live stream from Fluid Numerics. I'm Joe Schoonover, and today we're going to be talking about some strategies for managing your HPC cluster and other resources in the cloud, specifically on Google Cloud Platform. Today what we're really going to be covering is how to deploy an HPC cluster that has a Slurm job scheduler using Terraform's infrastructure as code. So we'll walk through some basic resources we provided for you to help you get started with that process. And then from there, I want to show you how you can use that infrastructure as code to integrate with Google Cloud Build and Google source repositories to automate the generation of Terraform plans. And of course, the execution of those Terraform plans to update your resources simply by collaborating on a team and pushing that code to a Git repository. So to kind of round everything off, we'll talk about some of the basic setups for a dev and production build triggers so that you can make all that happen. And in the end, what we really want to just set you up with here today is an environment where you can have your team of system administrators and those who are maintaining your cloud infrastructure basically collaborate on this on a Google source repository. In the first round here, you might be collecting a set of issues, feature requests, and other things like that from your end users on your HPC systems. And together as a team, you guys can work together to submit patches to your infrastructure as code to a dev branch and allow that to generate a series of Terraform plans that you guys can review as a team and then decide what features to merge in to then basically control the application of that Terraform plan to keep your resources up to date and functioning. So let's just go ahead and dive in. We're going to head on over to the Google Cloud Platform console. So if you need to get over there, it's just console.cloud.google.com. And we're going to start off just by showing you the repository, the example that you're going to get started with today. So two things here. One, if you head on over to GitHub, just look under our Fluid Numerics organization page, you'll find the Fluid Slurm GCP Terraform repository. We're actually going to be using that today. So you can go ahead and copy over the SSH or the HTTPS link to clone that repo. And then back on that console, go ahead and activate your Cloud Shell. And I actually like to pop this open in a new window. Okay. Once you're in that new window there, let's go ahead and set up our project. So today I'm working on a project called Cloud HPC Demo. So we'll set that project. And we'll clone that repository. Oops, Cloud HPC Demo. All right. So I'm going to make a new directory here. Let's call it Demo. And we'll go in there and we'll do a git clone of that Fluid Slurm GCP Terraform repo. So this repository provides some it provides a Terraform module for launching the Fluid Slurm GCP cluster. And if you're familiar with this from the marketplace, this is exactly the same thing, except we've also provided some examples that allow you to set up custom networking, sets up what we consider the best practices for the identity and access management policies, and a number of other resources. And of course, it helps you get set up with controlling and maintaining your infrastructure as if it were code. Underneath this repository, there's an examples directory where right now we have just the CentOS cluster that's there. Now you can actually use this solution if you're deploying an Ubuntu cluster as well. I'll walk you through that today as we're kind of modifying this repo during this demonstration. What we do need to do though is copy, like the first step here to help you get started is to copy that example into a new location, and we're going to create a Google source repository as your starting point. So let's go ahead and make a directory. I'm going to call it my HPC cluster, and let's copy the contents of that Fluid Slurm GCP Terraform examples, CentOS cluster. Go ahead and copy the whole thing. And we're going to put that into my HPC cluster. Oops, let's go ahead and get those directories as well because you're going to want those. All right. So if you go under my HPC cluster, there's a few things here, and you'll kind of get a feel for what's going on in this repository as we go along. But the place we need to start here is this fluid.auto.tf vars file. So the way Terraform ends up working is Terraform uses a declarative language called HCL, where we can declare all the resources we want to create, and then you can templatize that set of resources and provide a set of variables for people to tweak these things to tweak these systems specific for their organization or their GCP projects. So where you're going to want to start here today is like, we'll go with the basic deployment here that's provided sort of as is, just filling in some of the necessary information to concretize your cluster. So the cluster name, again, if you've deployed from Marketplace before, you've seen this variable in the past, but the cluster name is just going to be the name that ends up prepending the controller and login nodes. So if I were to call it demo, I'd end up with the demo controller and a demo login 0 compute engine resource. And then, of course, all the networking, subnetworks, and all that stuff will be named accordingly. I'm actually going to go ahead and call this, let's see here. Yeah, let's just call it my HPC cluster. Why not? The project ID is going to be the project ID where you end up wanting to deploy your controller and login node to, and of course any of those compute nodes in your compute partitions. So here we're going to be doing cloud, HPC demo, okay, and then the zone, I'll say US West 1B. Now remember, these clusters can be configured to be multi-zonal, multi-regional, and that's primarily done through the partitions on the compute side. By default, if you did just want to have everything in one zone, that's perfectly fine. Down below, you have the machine sizes for the controller and login node. And the cool thing about the infrastructure as code is, down the line, if you find that you end up needing to change these things, you can end up just coming into this TFRs file and changing it later. So you're not locked into those decisions. Now on the project, if you do leave it blank, the scripts that we've provided for you in this example will basically deploy that partition in the same project as the primary project listed above. There are a lot of use cases for doing multi-project deployments here, but not going to get into that today. And then, of course, the image, if you leave that blank, it will also default to the default Fluid Slurm GCP Compute CentOS images. Later in the tutorial, you'll see how we can actually modify those. And then down in the zone, you will need to fill in a zone that you do want to deploy to, so we'll go ahead and just leave everything in the same place. All right. So in addition to creating the cluster, like I said, there's some networking that's also configured for you automatically. And then we do set up identity and access management policies for folks that might be system administrators in your organization. And then those who are just going to be using the cluster to access Slurm and get some research done. So on Fluid Numerics side, we use Google Groups to actually kind of group our team that handles the system administration side. So you might you might consider doing that as well, or you might just want to list out, of course, user : and then the email address for that specific user. And we provided this as an array, so you can just create a whole list of people that are going to be serving as your system administrators. Folks in this group are going to be given the OS admin login permissions. And then they're also going to be given compute admin, so that they'll be able to go root on the GCE instances that are created, and then they'll also have some administrative privileges on the GCP console to be able to control some of that infrastructure after deployment. Now on the users, again, you can do basically it's the same principle here, except these folks, when the identity and access management policies are created for them, they're just given the compute OS login service account user role, so that they can basically just SSH into the cluster, submit jobs, and carry out their work in a safe manner. So here today, it's just going to be me. Of course, on your side, you could fill out whoever you need to have access to the cluster to submit jobs. Now the Slurm accounting, if you do want to use cluster services, which is a binary that we provide on our images to manage your Slurm accounting, you can fill this out here. Otherwise, you can leave this blank if you don't need that. And to leave it blank, what I mean is you'll basically close that bracket there and then delete these next 3 lines down below. Totally up to you how you want to do it. I will show you how to set this up today. So here is just the name of the Slurm account is really up to you what you want to provide. I'm going to leave it as demo account. The users are going to be the Linux usernames of each of the people, likely in this Slurm GCP users, possibly overlapping that Slurm GCP admins list. If you don't know what those POSIX usernames are, you'll definitely want to check out some documentation on the admin SDK and cloud identity to learn more about how POSIX accounts are generated on Google Cloud. The allowed partitions. So up above here, you see the partition name is set to demo. If you ended up changing that to something else, and you want these users to be able to submit jobs to that partition, you'll just make sure those partition names match there. But we're pretty much good here. So now the deal is, if you want to actually go through and see what this, well, I guess before we go too far here, we've got the repos set up. We've concretized some of these variables. Let's go ahead and initialize this as a repository, and let's make our initial commit. So we'll do a git add, just add everything in this directory, and we'll commit. Initial commit, and then down below, I'll just leave an extra comment. Duplicated from Fluid Slurm GCP Terraform examples CentOS. Okay, so that's really it. But now what we got to do in order to facilitate some collaboration between team members, you need to actually set up a Git remote that your whole team can contribute to. So for that, we're going to be using Google source repositories. So if we go back to the Google Cloud Console, you hit that navigation menu, go head on down to the source repositories. If you don't have any already, this should be blank down here. Let's go ahead and add a repository. We'll create a new, and let's call it my HPC cluster. Okay, and then select the project that you want to put it in. Okay, go ahead and create. And then what we're going to do is you'll be able to follow the prompts on the next screen to show you how to connect to that repository and push up those changes you just made in your Cloud Shell. So go ahead and select that option for pushing code from a local Git repository. And if you haven't set up an SSH key to be attached to your Cloud Identity account so that you can push to source repositories, go ahead and follow that first step there. Now I've already done it, so I'm just going to go ahead and copy that second line. Essentially what we're going to do is add a new remote called Google, and it's going to map to an SSH location for us, a location for us to push the Git repository over SSH. So let's go ahead and copy that and paste that line there. And now we can do a git push all to that Google remote. Okay, so now everything's up on the source repositories. Let's hop back over to that. I'll refresh this page and you'll see that that code is up there. Okay, so now we've got our Google source repository. You've got the basics here. Let's just take a look at what sort of the steps are here when you're using infrastructure code, specifically with Terraform to deploy your resources. So if this is your first time using Terraform for a new project, you'll need to run Terraform init. Essentially, this will parse the main.tf file in this directory, and it will look for any providers in this case, it's really Google providers, which gives you access to Google APIs to launch resources and any other modules. Okay. Now, if you were to do an ls-a, you'll now have this .terraform directory where all that information is stored locally. So the thing is, if you get into some of the details here and you really start modifying that main.tf and you're changing providers, provider versions, and modules and things like that, you'll need to run back through that Terraform init. Okay, so the next step usually when you're handling infrastructure code is to make a plan. So basically what we want to have Terraform do is look at the resources we have available, look at what Terraform's already deployed, and then determine what needs to be created, modified, or deleted. You can do that using a Terraform plan. Now, before we do a plan, I do like to run that Terraform validate, so it just makes sure that everything is actually syntactically correct. And once that looks good, you can run that Terraform plan. Now, of course, if you're starting from this example, all this stuff should be pretty quick and easy to use. We've tried to keep these things well maintained so that these work right out of the box, giving you a really good starting point. So there's a ton of resources to create here. So you can see we've got 25 resources to add, and this includes everything from networking, firewall rules, identity and access management policies, and of course that controller and login node that go along with it. Now, if you did want to actually create those resources, you would run Terraform apply. Now, if you're okay, basically, if you're just doing this at the console and you're okay with interaction, you can just run this. You'll get a prompt. It'll basically want to confirm with you that you want to make those changes. If you want to bypass that, as we're going to do when we set up the cloud build triggers, you can run Terraform apply with the auto approve. So what's happening now in the back end is a number of resources are actually being created for us. A number of APIs are being enabled. So if you don't have Compute Engine API already on, it's going to go turn that on so that you can actually create networks, firewalls, and all that. So this is going to take a few minutes. While that's actually happening, we need to move on to the next step here so that we can use Cloud Build to basically execute these steps for us. And then we'll talk about how to divide up those steps for doing the planning when we push to a dev branch and actually applying or creating the resources. So it looks like I already have a service account with this particular name, and that's probably from a previous deployment I've done here. So let me go ahead and clean that up. This is the joys of doing this live. So let me go ahead and clear out some resources from a previous demonstration. You shouldn't be running into this unless you've done this twice. So I'll run back here. Let's do that plan again. Okay, and then I'll hit that apply. All right, so while that's actually running in the background here, we do need to set up Google Cloud Build. There's a few things you need to configure so that the Cloud Build service account can set your identity and access management policies and manage some of your resources. So the first thing we need to do is use that products and services menu again. We're going to go down to APIs and services. And we need 2 APIs to be enabled if they're not already on your project. So one is the Resource Manager API. Okay, Cloud Resource Manager. Now, if yours is not enabled, this blue button will actually say Enable. Once it is enabled, it should say Manage. Okay, so if it's not enabled on your project, go ahead and enable it now. And then on the other one we need is the Identity and Access Management, or just IAM API. And again, mine's already on, but if yours isn't, go ahead and hit enable. That should take care of that. Now, the next thing we want to do is go into Cloud Build, and we're going to go to the settings. Okay. Now, in the settings, there's 2 of these GCP services you need to enable for Cloud Build to basically have administrative privileges on. So one is the Compute Instance Admin. So if it's not already enabled, hit that drop down, click Enable, and then service accounts. So you need to give that Cloud Build service account the service account user privilege. So go ahead and hit Enable there. And the last pre-configuration we need to do is head on over. Actually, let's go back one more time so I could show you one more bit of information that we need. So you're going to need this Cloud Build service account. Go ahead and copy that. Now let's go into that products and services menu to the IAM and admin. Go to IAM, go to add. Okay, copy paste that service account in there. Okay, and the role you're going to need to give it is the project IAM admin. Okay, and this will allow that service account to actually set those identity and access management policies that we're trying to control with Terraform. Now, keep in mind, all these things we just did in the console, you can also add those to your Terraform infrastructure, so you can control a bit more than what we provided you in that example. But I did want to walk you through all these details so you really know what's going on the backside here. Okay, so let's take a look at how our apply did. Looks like everything went through. And now if I look in this directory, I've got a terraform.tf state. Let's take a look inside of that. And of course, I've got a backup file for that Terraform state. All right, this is just a JSON database that describes all the resources that Terraform deployed and is now managing for you. So anytime you make changes to your auto.tf vars, your main.tf, Terraform's going to compare against that TF state and of course compare against what's also deployed on GCP and then determine what to do based on the changes you made. So now that we've got Cloud Build set up, we know how to do Terraform plans and applies. The next step is how can we use Cloud Build to actually make all this happen? So first, let's go ahead and make a change to our repository here. So let's say that we actually wanted to now use a new image. So first, let's take a look at that variables.tf. So this is a list of all the possible variables that we provided for you in this example. And what we want to take a look at is the compute image. Okay, so by default, right, it's set to this Fluid Slurm GCP Compute CentOS. Now, if you've seen some of our previous tutorials, we've created other custom images for applications like OpenFOAM, ParaView. We've got a ton more coming your way this year. You might be creating some of your own custom VM images for your applications, and you might want to be able to deploy those fairly quickly on your cluster. So let's see how to do that. So let's go to the fluid.auto.tf vars. Okay, let's come in here. And I'm going to just use this as my template because I can't remember this full string every time I want to type it in there. But now in this first partition, I basically want to have projects, fluid cluster ops. What do I want? I want to have OpenFOAM on this one. So if you recall our OpenFOAM image, it's still hosted on the Fluid Cluster Ops project, but it's just called OpenFOAM GCP. And now what I might do is change the partition name. Okay. and then come down here to the allowed partitions and change that from demo to OpenFOAM. Okay, and of course for that image, we actually do have to bump that disk size up as well, and I believe the minimum was 50 gigs for that image, but that should be good to go. And of course, because this is an MPI application, good practice for these HPC tightly coupled MPI jobs is to either use some of the compute optimized instances, so the C2s or N2s. Of course, you can try your luck out with the N2Ds. We've had some pretty good experience there recently with some of these finite volume applications. So really good to experiment with that. But let's say we ended up wanting to deploy this on some C2 standard 60s. All right, so we've made some changes. So if I were to look at doing a Terraform plan, what it's going to do again is it's going to parse what we have. It's going to take a look at what's there, what's already deployed, and I see we've got two things to change. And if you really want to know what's being changed, you can scroll back up and look for these spots with the yellow tilde there, and it'll show you what's actually happening. Okay, but essentially on this cluster, if we modify the partitions, what it's going to do is update the instance metadata so that you can then take that information and propagate it into your cluster and update your compute partitions and your Slurm accounts. Okay, so now the question comes, how do I get this to run on Cloud Build? Well, like I said before, that currently that database for all of our resources is stored in this terraform.tf state. And of course, if you're trying to collaborate, you can't just have something like that sitting in your local directory. And what we're actually going to do is show you how to set up your main.tf file so this offloads that TF state into a GCS bucket. So the first thing you're going to want to do is head on over to the console again, use that products and services menu, hop on down to storage. I'm going to create a new bucket today, just so in case you're not familiar with how to do that, that's all right. We'll create a new bucket, and I'll call it my HPC cluster and TF for Terraform. So we'll go ahead and just run through this pretty quickly. I would say review these options for what you're doing here. Some of the defaults are going to be fine for this tutorial, but make sure you have some consideration about where you're placing the bucket and the type of access controls you want to give. Let's go ahead and create. Once this is done, I've got an empty bucket called my HPC cluster TF. All right, so at the top of that main.tf, we've left a spot for you. It's commented out. It's between these few lines here. So let's turn on that line numbering. So in the lines 2 through 9, we're going to go ahead and uncomment that. So we're basically setting up the back end where to store that TF state. Up here, let's go ahead and change this to the name of that bucket, which is my HPC cluster TF. And of course for you, you'll put that as whatever you want. We don't need the prefix today, so you can go ahead and just remove that line. Now that you've changed the backend though, you actually have to rerun that Terraform init so that it copies that local TF state back up to the cluster. And that's essentially what this question is asking you. Do you want us to copy the current state you have in your directory up to that new backend? Okay, so I'll clear that. Let's go back to that bucket, refresh, and you'll see now that now that we've basically reconfigured that TF state file is now up here. Okay, so that's step one outside of some of the pre-configuration work we did there. Now, other things we provided for you in this example, if you look under that dev directory, there's a cloudbuild.yaml file. This is a file that just provides the steps to Google Cloud Build that need to be taken in your build environment. So let's take a look at that. So essentially, we got one step here. It's going to use a Terraform build step. We changed the entry point to sh so we can run these three commands kind of all in one go. We're going to run Terraform init. We're going to run that validate. If it doesn't validate, it's going to exit with a non-zero exit code, and then we run a plan. So the idea here is that what we want to have happen is when someone pushes to a dev branch on your repository, this cloud build ends up getting executed. But let's first take a look at what happens when I run this manually. Now, if I've done all this right, this should work fairly straightforward out of the box. So you'll do gcloud build submit, use the current directory. This basically specifies that we're going to take this directory and everything underneath, bundle it up and ship it up into that cloud build service. And then we're going to specify as the config as dev cloudbuild.yaml. And I like to use async so that I can get my terminal back, and we'll actually take a look at those build logs. So while that's happening, I did want to show you some of the resources we have created so far. So since we've done that Terraform apply already, you'll see that I have actually 2 clusters going right now, but the ones we just created here are the my HPC cluster login and the controller. And of course we have associated networks and firewall rules with that. So you can see down in the network interface, we got the my HPC cluster shared network, and the subnet is set as the controller subnet. So if you wanted to dive in to see more of that stuff, you can hop through the console to convince yourself that all that stuff is actually there. Let's take a look at how we're doing on the cloud build side. So this is basically a manually triggered build, and you can see it's actually happening right now. So it's going through and running that Terraform plan. So let me go ahead and expand that. And again, we get that same output we did when we ran the Terraform plan on the console. So that's looking pretty good. So the next thing we want to do is actually just go ahead and set up some of these triggers. Okay, so let's go ahead and collapse this, and from the cloud build menu, go ahead and head on over to triggers. I already have some here, but we're gonna go ahead and create some new ones because this is for a different demo I was doing. So we got my HPC cluster. TF will be the name for this first one. So this first one we're gonna configure so that whenever I push to a branch called dev, it's gonna execute that cloud build underneath that dev subdirectory. Okay, so this is gonna execute, or let's say create Terraform plans when we push to dev. All right, so the repository, since we've set up a cloud source repository, we'll be able to click through here. So we'll say my HPC cluster, and again, dev. All right, and then on that cloud build configuration, make sure you're clicked on that, that it's a cloud build configuration file, not a Docker file. And then just do dev cloudbuild.yaml, and we should be good to go. Okay, now let's go ahead and do the main one. Although we haven't looked at that cloud build file, let's go ahead and set that up. So we'll say my HPC cluster main. So this is going to apply TF plans when we push to the master branch. Now, if you end up having a different default name for that main branch, that's fine too. So let's say, all right, we got my HPC cluster. We'll push to master. That is just the default name that comes with that Google source repository. So that's what we're going to use. And the directory we have in that for you is main, where that other cloudbuild.yaml is. And before I hit go on this, there are some substitution variables we need to fill in. So let's hop over here and take a look at that. So if I go into main, okay, let's take a look at that cloudbuild.yaml. So we got 2 steps in this one. Again, we're doing that init validate plan workflow, and then we actually go through and run that Terraform apply with the auto approve. And again, if any of this fails, we just have it exit. Nothing else happens beyond this step. Down below, we actually have a step here that will execute some commands over SSH to run cluster services to update your configuration on the system. So this first step here, cluster services update config, will pull down the instance metadata onto the cluster, and then the next step here will actually run through an update all to update your partitions, Slurm accounts, and any mounts you have changed. The substitution variables here that we need to work with are the controller, which is the name of that controller instance, and then the zone that resource is deployed to. Okay, so let's go ahead and fill those in. We'll add 2 variables. The first one is going to be called controller with that underscore in the front, and the name. Remember, let's actually open up the compute engine. If you don't remember it, the controller name is just going to be the name of your cluster dash controller. Of course, if you ever wanted to find it, you can go to the GCP console. So this is what we want here. Let's go back to that trigger and drop it in. Make sure you don't leave any extra spaces there. And then the zone, again, I'm in US West 1B. Now, again, I'm showing you how to do this all through the panel. All of these things, including the triggers and the additional stuff we set up initially, can be done through Terraform as well. All right, so that's our triggers here. So now let's try this out. If I were to basically come back to my repository and create a new branch called dev, let's say git checkout -b dev. Okay, we have some files that we've modified. So we have this fluid.auto.tf-vars. Okay. And what else did we modify? We modified the main.tf so that we would actually have that GCS backend. All right, so let's commit this, and let's say we swapped first partition for OpenFoam. All right, so now let's push that up. Whoops, because this is a new branch, we need to say git push -u, and then we'll put the name of the remote, which is Google, and then what we're pushing to is dev. So basically, I've shown you two things now. We ran the Terraform plan manually, and then we ran the Terraform plan by manually triggering a Google Cloud build, and now we're triggering a Google Cloud build by using an automated trigger so that when we push to dev, we actually get a build that happens. And remember, this build, all it's going to do is run that Terraform plan. So you can see it validated, and it's doing the same stuff we did before. So at this point, normally what you would want to do is decide on how you would review these Terraform plans, and then basically get yourself from a dev branch into a main branch so that you can basically apply the changes that your team agrees to. So let's say we're at that stage. The next thing we would do, now if you wanted to do it manually, of course you can come back to your Git repository and designate someone to manually merge from dev to main and then push that change up. Another route to go is to use something like Cloud Functions or Cloud Run, and then some type of endpoint to trigger that to happen automatically for you. Today we're just going to keep it simple because we're just focusing on this main pipeline, but keep in tune to what we've got coming for you. We'll definitely be touching on things like that throughout this year. All right, so we're at a stage where we want to merge back into the master branch. So let's go ahead and check out master, git merge with dev, and then we would push again up to that Google remote. And we'll give this a second here, and we'll see that other trigger come through. That's pretty much it for today. So what's going to happen here is it's going to go through and update those partitions, and then run the cluster services update command to get all this to work, to basically apply all those changes to our partitions and any Slurm accounts or any other changes we made. So I hope you guys found this useful and informative. If you do have any questions, feel free to reach out to us on the chat here, or of course you can always reach out to us at fluidnumerics@fluidnumerics.com. It's a public Google group where we're always available to answer any questions you have about using these resources to get your research done. So thanks again for joining, and we hope to see you guys soon.